Hello students, today we are in lecture number 6. Lecture number 6 of chapter 1, Electrostat. This is B.S Pandey. Students, I got number of mails after my 5 lecture, and so I'm going to few questions of previous year. Students eagerly ask, sir, if you can discuss few board questions. So students, one of the very important question till the topic we have been covered is by the induction. Here I am giving you the question. Suppose student, we have two neutral body. Two neutral body, identical body, and these two neutral bodies are in contact, say A and B. If a negatively charged rod comes near to the first sphere A, okay, so you have to show the charge on sphere A and B. So the charge distribution on both the sphere A and B. We have discussed already about this topic, induction. Could you solve this question, student? If you can solve, pause the video and try to solve it. Otherwise, I'll give you the answer. Okay, now the answer. Actually, the question is, if you touch this sphere, if you bring this rod near the sphere A, which is connected with the sphere B, that is in touch with the sphere B, and after removing this rod, how does two body get charged? This was the question. Now, if these two body A and B are neutral, remember again I'm telling you these two are identical. That's negatively charged rod. What will happen, students, since these two A and B are neutral body, both are neutral body, so equal number of positive and negative charges are there. So the plus will appear near the rod and minus will move away. This minus will repel positive away and negative will appear, this negative will attract this positive one and negative will move away. Now in second case, if we move this rod away and separate these two sphere A and B, what will happen? We bring this rod back away. Here positive, this negative and positive will neutralize itself, and here positive and here negative. So this was the initial condition and this is the final condition. So what will be the final condition? So the final condition will be A and B get charged, uniformly distribute this positive charge over A, and over B negative charge will uniformly distributed. So this is the answer. In this way you have charged this body. If you understand well, students, try to solve another example. This is your classwork. This question has been asked in previous year. Now I'm giving you the same case, same situation. There's two identical body, A and B. Okay, A and B. But now you are having positive charge, positively charged rod. Okay, what will be the answer? Second question. Student, you have to send the answer if you correctly solve this question. Now the second question, again you are having two body, A and B. Remember, this is the neutral body and identical. From one side we bring positively charged rod, and from other side if we bring negatively charged rod. This is the initial condition. This is the initial condition. What will be the final charge distribution? You have to find in both the question final charge on A and B. Okay, so this two question. Would you like to have some more interesting question on this topic, students? Okay, one more. Okay, one more. Now I'm giving you some interesting situation. Okay, another question. This is your classwork. Okay, now this will be your assignment. Okay, assignment. After lecture you will try to solve this question. This two identical body A, B. Now this is positively charged rod, and this is also positively charged rod with the same strength. These two have the same strength of charge, and both the A and B identical. You have to show the charge distribution. Okay, so this is the first assignment, and the assignment number 2. Now okay, let me try to solve a question in which we are having three identical bodies, A, B and C. Now in this case you have to show the same charge distribution. If positive charge rod bring near the sphere A, which is connected with the B and C, again you have to find that is the show the charge distribution. You have to show the charge distribution. Okay, students. Now, a very important point, students, try to keep in your mind. If two body, actually we have discussed already in last lecture. Kindly note down. If two body, identical body we are talking. In the next chapter we'll talk about the two bodies of different shape and size are connected by this conductor. Okay, conductor. This body having charge q, and this is neutral body, and this is the conductor. Okay, so this is the initial situation. What will be the final situation? So the final situation you have to find. What will the final situation? So the final situation will be there will be conduction of charge, as we have discussed. Try to remember. This is the body, body A, the charge q. This one has the charge q. If it is bring near the second body, then what happened? The total charge will be 2q. Then after, charge will distribute equally among the two body. Okay, in same way we'll try to solve and recall it. There will be the q, and here neutral body, it means how much charge it is. Q equals to 0. So the total charge will be q total. It will be how much? Q, and equally divided. This charge will be equally divided on both the sphere of A and B. Okay, so the answer will be on A and B, which is connected with sphere. The charge will be, final charge will be q by 2 and q by 2. Okay, such type of concept you have to use in questions. Another thing, students, we have finished Coulomb's law. Okay, we have finished. We have studied already Coulomb's law. Actually, today I start with the recap of the few topics we have already covered in previous lectures. So we have discussed Coulomb's law. What is Coulomb's law, students? Yes, Coulomb's law. It is for the 2-point charges, and 2-point charges separated by a small vector distance. Then we write here the F is equals to K, which is a constant, Q1 Q2 divided by R square. If the medium between these two charges will change, then the value of K actually does not change, but the coefficient, it is called the permittivity, it changes, and it comes with another factor we'll discuss later on as the dielectric constant. Okay, if question is asking in 1 marks, because CBSE changing day to day its pattern, if the question is asking to plot the graph between this force and separation, keeping this two constant, already K is constant, then what will be the nature of this graph? Okay, you have to plot the graph between this force, which is in Newton, and the separation, which is in meter. I hope you can plot the graph. It is y inversely proportional to x square graph. So the graph will be in this way. Remember, students, this graph, in this graph, on the y-axis, this graph will not kiss this y-axis, and this is not kissing at x-axis, because as you will touch this graph with the y-axis, the force will be maximum for r equals to 0, which is not correct. Okay, so we are not touching this graph. This graph is the very simple. If question is asking to plot the graph between force and separation between 2-point charges, then you have to plot such type of graph. Okay, students, next question of this lecture 6. The one question: suppose a student, you have a charge. This is question. You can say this is your assignment. I understand that you got too many assignment today. Okay, student. So another. Suppose you have a charge Q. Okay, this is the charge Q. Now the question is asking, you have to divide this charge Q in 2 parts. That is, you have to divide this charge in 2 parts. Okay, one is Q and the another one is Q minus Q. Q minus Q. Now the question is asking a charge Q, that is this amount q is divided into two parts. Okay, try to write the question. This charge q is divided into two parts, q and the another will be q minus q, such that the two parts exert maximum force. Remember, I'm not giving any condition for the separation. The charge divides into two parts, q and q minus q, such that these two exerts maximum force on each other. Then you have to find the ratio. You have to find the ratio of q upon small q. I hope you understand the question, students. Now try to solve. Since this is the assignment, I will not solve this question over here. If you will find, then we'll solve this question in classroom program, or you can leave your comment and I'll give you the answer. You can mail me also. Okay, now the next question. Okay, this question I'll give you hint. Next example, actually, and this type of example may be asked in competition. This is not very important for your board, but this type of question may be asked in your board, competition. Okay, question. Before giving the question, I'm explaining a simple condition. Suppose this is charge q, okay, plus q and another plus q. If you place a negative charge minus q at center, okay, this is placed at center, what will happen? Net force will be 0. F net will be how much? 0. Already you have been studying in standard 8th about the equilibrium. We have solved few questions for equilibrium also in last lecture. So this charge will be in equilibrium and this is called the stable or unstable. We'll check. Okay, but this is in equilibrium since this charge have the net force 0. Remember, these two charges are fixed. They cannot change their position. These two are fixed. Okay. What will happen, students, if this is the charge of magnitude minus q and net force is 0? What will happen if we'll disturb this charge very small by the very small displacement? Suppose I displace this minus q charge towards right or towards left, whatever, right or left. It is quite obvious that the net force at this point is 0, but what will happen if we will disturb this charge towards right by the very small distance? Okay, so try to check what will happen. If you can analyze, then analyze by yourself. This is minus q charge and this minus q will comes at this point. Now here on this charge there will be two forces, plus q and plus q. Now this is center and charge is over here, minus q. This is the distance, suppose x, and this is the distance r minus x. Obvious, this r minus x is greater than x. Okay, this x is smaller, r minus x will be larger. You can see easily. Now there will be force. Since this is negative and this is positive, what will happen? It will attract towards this positive and it will attract towards this positive also. But which force will be greater? If it is F1, it is F2. Since this distance is smaller, so force will be larger. That is, F1 will be greater than F2. And if F2 is smaller, F1 is larger. If we are displacing minus q from this point towards this one, what will happen? It will go to just stick with the plus q at right side. Okay, clear? Very good. Now I am going to change the situation. If we place a positive charge, plus q, we are having all the things that is the separation L, mass of this charge also, the very small mass, suppose M. Now, if we will disturb this charge from its center towards the right or the left, what will happen? Suppose this plus Q comes to this point. What will happen? Now, this charge will repel and it will move towards this one, and this will repel towards this one, but this force will be larger. It means you are displacing this positive charge towards this one, but this charge is repelling this one to go to its initial position, and this condition is called a stable equilibrium. If particle try to regain its actual position, then it is called stable equilibrium, and all the particle and body in stable equilibrium try to oscillate, and since this displacement is very small, then it may be simple harmonic motion. Now, student, you have to find the time period. The question is actually you have to find time period. Find time period of oscillation. You may be asked to find the frequency also, but this time you have to find the time period. Okay, if you will have the time period, then by reciprocating you can find the frequency also. So this time you have been asked to find the time period. Okay, how you will find the time period? As you know that for oscillation, restoring force will be responsible. So the restoring force here you have to find, and restoring force will be equated by the mass times acceleration. Suppose the mass of this particular charge is q and acceleration will be due to change in velocity, it is acceleration a, and then after you can find out the time period. That's why I've been given you this question. Student, if you are not able to solve this question, then you will comment, or we will solve this type of question in our classroom program, students. Now student, if you will be capable to solve this question, for practice you can have another question for your assignment. I'm giving you, suppose it is the same question. Suppose if it is minus q and this is also minus q and the separation is L, and we placed here plus q, whether this charge is in stable or unstable equilibrium. If it is in stable equilibrium, then it will oscillate in simple harmonic motion. With simple harmonic motion it will oscillate, and you have to find the time period. Okay, you have to find the time period. In this question you have to find the time period. So such type of question will be asked in competition, student. Okay, there are a number of questions you will be asked in competition, and few questions you will find in my assignment also. Okay, the written assignment, there are more than 100 questions for your practice. So students, today's lecture we have been discussed such type of question. In next lecture we'll try to find the force on rod, ring, etc. using Coulomb's law, students. Okay, so in today's lecture, thank you students.